So, good morning to all of you, to respected teachers and my lovely friends. So, I am going to presentation on reduction to canonical form. So, my name is Shurajit Pal, roll number 4. So, here is my contents, introduction, working rule to reducing canonical form, example, conclusion and references. Introduction. A partial differential equation is a relation contain one or more partial derivative of a function and dependent on one or more independent variables. And the second order partial differential equation is this: capital R S plus S S plus capital T small t plus f of x y z p q equal to 0, where r s t are continuous function of x y. The second order partial differential equation is classified into three forms. First of all, hyperbolic if s square minus 4rt is greater than 0, and second, if parabolic if s square minus 4rt is equal to 0. Elliptical if s square 4rt is less than 0. And the working rule for reducing to canonical form. Here are the working rules. There are 6 steps. So here are the working rules: first step, second step and third step. With the help of working rule, you are going to solve a problem. So here example: reducing flowing equation to canonical form. So first of all, we are taking the given equation and we can write like this: small r plus x square t equals 0, and comparing with equation 1, comparing with this equation. After that, we can find the r, s and t, and we put the value in this equation. Then we can find the equation is parabolic elliptical, so we get the from this equation we get the equation is elliptical. After that, we are find the quadratic equation is this is the quadratic equation, where we get the lambda, and after that we find the characteristic equations. These are characteristic equation: dy dx plus lambda equals 0 and dy by dx plus lambda 2 equals 0, where dy lambda 1 is I x and lambda 2 is minus of ix. After some calculation, we find this equation: dy plus iota x plus dx, dy minus iota x dx equals 0. So we integrate. After integration, we can find this, where c1 and c2 are the arbitrary constant. Now we choose u and v, where u is y plus iota x square by 2 and v is y minus iota x square by 2. We let the u equation is alpha plus I beta and v equal y minus I beta, where alpha is y and beta is x square minus 2. It's equation 2 are are two new independence. Alpha and beta are two new independence variables. Now we find p. We know that p d z by del z by del x. So we, with respect to alpha and beta, we can find the p. So here is the p. Number 3, similarly we can find q. After that we know that r is del square z by del x square, where we can common del by del x. So here we'll find that del z by del x, where del z by del x is p. So we put the value of p and some calculation. We find that r is del z by del beta plus x square del square z by del beta square, where similarly we can find t also, putting the value t is z square by del y square. After and put x and put r and t in the equation 1. After calculation we get the equation. This is the final equation we get, and which is canonical form. Now here we conclusion. Here I have to came to in the presentation on the topic of the reducing to canonical form. I would like to conclude that the second order linear partial division, that is r square capital R small r plus s small s plus t plus f of x y z p q equal to 0 is converted into a canonical or normal, so that it acquires a simple form, and then solving it's become much easier. So here the reference ordinary and partial differential equation by MD Raishangania, and we also take help from YouTube so as well. So thank you.